Thanks for coming our tutorial 7. As mentioned, tutorial 7 covers two parts. One is for the composite beam. The other part is on buckling. Of course, these two parts are very important for exams because they are very common and have been widely used in real industry problems. We'll see the first question is on the composite beams. The wooden section of a beam is reinforced with the two steel plates, as we show here. So determine the maximum moment M that the beam can support if the allowable stresses for the wood and the steel are sigma allowable for wood is a 6 megapascal, sigma alloy for steel is 150 megapascals, respectively. Take the Young's modulus of wood is 10 gigapascal and steel is 200 gigapascals. Of course, this one is typically the two parts, one with steel, one with wood, is a composite beam. Okay? For the composite beam, of course, we mentioned to you the composite beam could be with a lot of things with a transformation. Of course, the most important thing, we should get the idea what kind of way we should transform. So of course, the two ways, one is transform from material from high stiff to low stiff, or from the low stiff, so from low stiff to high stiff, or from high stiff to low stiff. But doesn't matter which way to use, we must know the way, what kind of material should be transformed. Okay, and the equation will be used for us. So of course, based on here, we mentioned to you this maximum moment of M that can apply, and also is a allowable stress of this thing. Of course, from the knowledge we know before, sigma max will equal to the N C over R. Okay? Of course, this equation, so it's very important for us to know that from the maximum normal stress. Okay, of course, the C is a very important C. C is the farthest, okay, position. Okay, from neutral axis. This from the previous knowledge. So we'll say the given parameters first. The sigma allowable for wood is equal to 6 megapascal. The sigma allowable for steel is equal to 150 megapascal. The Young's modulus of wood is 10 gigapascals. The Young's modulus of steel is equal to 200 gigapascals. And the width of wood and steel is equal to, here is 0.1 meters from here. So as we mentioned, this is the composite beam, and we will try to use the low stiffness material to be replaced, or we transfer the low stiff material into high stiff material. So for here, if we want, that means the wood has a low stiffness because only about 20 gigapascal. The steel has high stiffness at 200 gigapascal. That means we most will transfer the wood into steel. Clear? So now, what's the N will be? Transformation factor will be how much? Remember, we'll transfer wood into steel. So this is correct? It's correct? Why? We must transfer wood to steel. Wood must be should be on the top. So transform wood into steel. Clear? Okay, that's the way. Okay, so that means from here 10 gigapascal to 200 gigapascal. So that means 0.05. So now we should work on the next step. We should work on the width of the transformed parts. Clear? So that means we should work on B prime steel. Remember, this is not real steel. Okay, it's from transform. Should be equal to MB wood. Is it clear? Is it clear? Someone from previous examples, many students will put it this way, is B steel. So this is wrong, okay? So that's why from here, we transform steel or transform wood. We transform wood into steel. So that means here, it's not actual, it's from the transformed parts. So with steel, so that means 0.05 times 0.1 equal to 0.005. Okay? So now we should draw the structure here. So that's why I can see the structure. So you should draw roughly, okay, structures here. Clear? So that's why from here, we get a structure. This side is 0.1 meters. Okay? And this one is a 0.015. Okay, this also 0.015. But the whole distance is 0.15 for the whole thing. So that's a new structure. So this means this one is the parts. But because of the I-beam, we did a lot of times, okay? So that's why I will not give you all the details to show you. So the neutral axis should be within the structure. So that means in the half of the height, half of the center of these things. So that is a neutral axis. Clear? So that's the easy way for us to work out. So that means from here, we can know that the neutral axis is the middle way. So we don't need to work on a Y bar. That means we can get it very easily. So now the next step, we only work on the I. The I is I-beam. We've worked this so many times, okay? I will not give you all details again and again. Just because it's many parts, we can work out. Okay? So for here, I can work as something as one big block, as I mentioned in the lecture 2. I can have one big block and less the way. Okay, so that's why I use this way to do workout. So B times the width times the height. The height is like this way. Okay, cubic minus this way is a 0.1 minus 0.005 h cubic. So of course we can get these things is equal to 21.88 times 10 to -6 meter per 4. So remember, you must do this thing by yourself. Okay, we have so many practice of these things. We cannot repeat everything again and again. So that's why we never end for this thing. The main thing here, so we know this one is thickness. So B steel prime. Remember. So that's why for here, we can work all these things. We can work out very easily. So we can work out. So that means from here, we can get I. But remember, we're going to end the sigma max. Okay, this is only for steel. It's equal to ms c. Remember, this is steel, okay? Over r. So, of course, should be equal to sigma allowable for steel. Remember, steel will be on the top, anyway on the top. I'll put the color to show you. I'll put this color to show you. So that's way always on the top, all on the top, farthest way. That's for steel. Okay, this is for steel. That's why for here, for M, we can work out. For is a sigma allowable steel times I over C steel. So that's why we can get it work. So 150 megapascal times I will just work out times 10 to the power 6 meter per 4 over C steel, of course, the farthest way. So that means this will be half of the 0.15 plus 0.015 divided by this halfway plus the height. So half 0.15 plus 0.015. So the farthest way. So that's why from here we can work out 36.5 kilonewton. So this is from steel itself. But remember, so the wood we didn't know because it's not real one. That's we still work on the wood part first. Same way. So wood part will be underneath. So I will use the way to show you that this underneath way will be under this farthest way for wood. So that's why for wood, which will do the same way. So sigma max prime for steel. Remember, this is not real. Okay? Should equal to n c prime s steel divided by I. That's for green color for that, for wood parts. So of course, sigma max for wood should equal to n sigma prime max for steel. Should be equal to sigma allowable for wood. So that means we can do further work. N C prime steel over R equal to sigma allowable wood. So that means for M is a sigma allowable wood times I over C prime steel. So remember, this one will be different. Okay, we put it here. This is 60 sigma megapascal times 21.88 times 10 to the 6 meter per 4 over n. Don't forget n. N we just work out is 0.05. I put the values here. Okay, times this value, because this one is for the not real steel. It's a real with green color. Sorry, for the green color parts. That is the half of the 0.0 is 0.15 half of this thing meter. So remember this one I use a green color to show you. That's green color. Okay, so this one is for wood. So as well from here we get the N is a 35 kilonewton. So because 36.5 kilonewton is greater than 36.5 is greater than 35 kilonewton. So maximum moment will equal to 35 kilonewton meter. So it's kilonewton meter, okay? So that's why we should think about this way. So this is why, because the wood part may be broken, okay? So that's why for here, we must get this idea. The first part, we should know what to be transformed is very important for us. So first thing, the n. How we can work on the n? You will see from week to any calculations. So you will see this value is very important for us to know. So that's why from here, we can get all the values. So from here, we get this equation. So allowable of the wood, this one should be good for work. So the one for n is very important for us to realize for the composite beams. This is very, very important for you to find. How we can work for n is very, very, very important. Okay? The material to the transformer is the up, and the other transformation in the material is in the bottom. That's the way. Okay, don't forget, this is very, very important for us to realize. Okay, this question was similar to the last year standard, I think, no, deferred question, this one. Okay, I think deferred standard, I can't remember. Last year we showed this question, but we changed the parameters. Okay, yes, please. N prime doesn't matter. N prime doesn't matter. Just to show the difference, you can use just use n to show these things. So the n is just a transformation factor. We use the n or n prime to show. So from high to low or from low to high. Doesn't matter for these things. Okay. For me, I prefer use n. You just use n. You can do any time for it by yourself. But we must know the meaning. What's the n? The n is from the top, the material to be transformed to the transformed parts. So that's the material will be on the bottom one will be the material. Okay. So this is very, very important for you to realize. And we can use another example to show you. Okay. Then you have a question ask later on. Okay. Yeah, we use another example to show you. Okay, we see another question. This question was a last year standard question. This one, last year finding a standard question. Okay, just show you. The composite beam is made of steel. For example, there's A. Part A is from steel. There's A is here. Everyone look at it here. This is A. This is a part. Okay, and also to brass. Brass is B is here. Okay, that's why one is a steel, one is a brass. And has the cross section show on the slides. So you can see 175 millimeter height. So for the steel is with 50 millimeter thick, and the brass was 200 millimeters thick. So if it is subject to a moment of M, so the M will show you here. So with 6.5 kilonewton meters, determine the maximum bending stress. So in the brass and the steel. So also, what is the brass in each? Also is the stress in each material is to the seam, okay, where they are bonded together. So that means on the junction, okay, location. So tell you the brass stiffness is 100 gigapascal, and also steel has a Young's modulus of 200 gigapascal. Again, we see the question itself. So determine the maximum bending stress. So the maximum bending stress, so that means the sigma max is equal to MC over I. Again, the C is farthest away. I will write down again. So this from lecture 6 and tutorial 6. It's the farthest way. Of course, it's the farthest way. But for any location, for example, for the location sigma will be equal to negative my over I for any location. Okay? So that's why for this thing, we must get the idea. We'll write down given parameters first. So the N here will tell you is 6.5 kilonewton meter. The Young's modulus of a brass will be equal to 100 gigapascal. The Young's modulus of a steel is equal to 200 gigapascal. And of course, the width of a steel, or let's say this is for the same brass, equal to the widthness of a steel. So that is a 175, the 0.175 meter. Let's give it parameters. Okay, of course, for this question, we have many ways to do. We still can transfer from high stiffness to low stiffness, or from low stiffness to high stiffness. Generally, we recommend you to use low stiffness to be transformed into high stiffness because to save space and save material. Because last question will show you, will transfer low stiff material into high stiffness material. No, I use another way. I transfer from high stiffness to low stiffness material. Okay? So I say, this time I will use high stiffness to low stiffness. Now, what's the N? We work together. N is, which one is high stiff? Which one is low stiff? Steel. Okay? Steel is high stiff. Yeah? And brass low stiff. So this time if I transfer high stiff to low stiff, so what's the N will be? We work together. Is equal to Young's modulus of brass to Young's modulus of steel. No? Why? Yeah, I say because this time we use high stiff to low stiff. Yeah. So that's why here we use the one way. That's why we should understand this question. Okay. So this one with the steel, we transform steel into brass. Clear? Then the question will be equal to 200 gigapascal over 100 gigapascal equal to 2. Then all the materials after transformation will be with brass. Clear? So that's why for here the B brass, but this one is a prime. Clear? Should be equal to NB steel. Remember, we transfer steel into brass for this kind. Okay, so it means 2 times 0.175 equal to 0.35 liter. So now we draw the dimensions. So that's why here, the steel 175 will come to bigger parts. Okay, and then in the bottom way will be brass. Okay, so that means here, this one is steel, but this one is a brass now. So that's why here, 0.35. This one is 0.175. Okay, this thickness is 0.05. Okay, that thickness is 0.2. Okay, of course, this one is a symmetry. So of course, we can see there's a symmetry in this way, but we know where's neutral axis. Neutral axis somewhere. They say somewhere. It's a neutral axis. Clear? This one also T-shape, so we can work very easily. We can work out. Let's say This is from top. This one is a y bar. So we can work on the y bar. Summation of a y bar A over summation of A. This is from definition. Clear? So there's two parts. We also use color to show you. Okay, it's a bar, the color yellow area. So I use this one to show you. So we work at this one for the top one. Top one is a 0.05. Halfway is a half of the 0.05 times the area is 0.35 times 0.05 plus the bottom one, the height is 0.2. So that means half of the 0.2 plus the top also have a 0.05. That's a y bar times the width times the height of this thing. I use color to show you, okay? This is the area, this is the area. This one is the y bar for each of these things. So then summation of here 0.35 times 0.05 plus 0.0175 times 0.2. So of course, based on this one, we can work out is 0.10833 meters. So that's why from here we can work out. Of course, same way we can work on the I. I again, so there's two parts. One is a top rectangular one, and the bottom rectangular one. But must find anything with use parallel axis. Okay, remember I is equal to summation of IC plus AD square. Okay, of course for any rectangular one, as we mentioned before, okay, if it is Z, IZ is equal to 1 over 12 BH cubic. It's a B, is a H. So the dimension. So let's be from here, the 1 over 12 times B 0.35 H cubic 0.05 cubic. But because this one not on the neutral axis, so we should put here area times D. D, we can see is a y bar minus half of these things. So that means 0.10833 minus half of this value. So square. Plus the bottom one. Bottom one is B times height plus area times this one. Then of course distance, half of the 0.2 plus 0.05. So that is the position minus 0.10833 cubic. So then we can work on the answer is a 0.3026 times 10 to negative 3 meter power 4. So remember, you must know how can work on the y bar, how can work on the R. So this is a very basic thing for you, okay? And of course, from engineering mechanics, from existing knowledge. If you don't know, we still get anything from lecture 2, and then we also get all the steps from the lecture 4, lecture 5, lecture 6. You should work on these things. So of course, based on this one, we can work out. Because this one, we can see the I will get it. M will give to you. So that's why we should all find the position. So the position we can work out for the sigma bros, okay, for the max. Remember, this is for the real one, okay, sigma max. Sigma max, of course, the halfway. This one, the farthest way. Farthest way should be on this side. Clear? On the farthest way. So of course we can get these things. And B C plus over R. So you can see 6.5 kilonewton meter times C plus. Of course, we can say the whole height is equal to 0.05 plus 0.2 minus the Y bar is a 0.10833 over the I will just work out. So now, of course, we can work out this things is 3.04 megapascal. Remember, this one's in tension because in the bottom is in tension. Clear? Some way we can work on the parts for the steel. But remember, we should say sigma prime plus max. Remember, this one sigma prime is not real. It's only from the transformer parts. So it's one from M C plus prime over R. So now, of course, we can see sigma steel max is equal to N sigma prime plus max. Clear? So this one from the equation, so other transformation. So then we can do further, we can work out. Is M C B prime, okay? And of course, this is there, put this, we'll put it down for you, otherwise I cannot write down. So that's why for sigma steel max, we will see the N copy M C plus R. So this is equal to 2 times M is 6.5 kilonewton meters. C max on the side, on this side, on the top side, okay, here, on this side. Okay, so what we see times 10833 meter over I, which is 1.3026 times 10 to the negative 3 meter power 4. So that means we can see is 4.65 megapascal. This one's in compression. So the value we can see will be a lot of different. So that's why from here we can get the values. Okay, the value we can work out the maximum. But still another question we say at the scene, what is the stress in for each part? So that's why for listings, 8 scene. So we can see we should write down the sigma plus we're equal to negative M C plus over I. So of course we can see negative 6.5 kilonewton. Of course, this one, remember this one, don't put the wrong thing, okay? This one still plus, that's on this one, you see here. This one still on the plus, it's above, okay? So that's why from here, we can work out 0.10833 minus 0.05. So that's why I can see the distance will be, I show color to show you here. Okay, you should know how to get a location. So that's why from here we can get it. Then further, the I is there, 0.3026 times 10 to negative third power. So meter power 4. So equal to negative 1.25 megapascal. You will see this one in compression. Okay, so I'll just write down for you. So this one also in compression of this. Same way we can work on sigma plus prime. Okay, so equal to negative MC plus prime over R. So of course, this one at the same location, negative NCBR over R, because on the same location. So that's why sigma steer will be equal to N sigma plus prime, will equal to negative N and C plus over R. So this one will keep same. So it's a 2 times negative 1.25. So that's why we can see negative 2.5 megapascal. Also in compression. So you can see steer and the brass on the same location, the value will be different. Clear? So it's about for here, you can get this idea how we can get the values. So we only have two equations. So these two equations from last lecture and the last tutorial. But we get one more to work out n, and get one thing of n sigma prime of these things. So it's about from here we can see from single material we can work out the multiple material. We can work out very easily. Okay, so remember one thing. This only new thing is the n. How can work on the n? N is equal to the Young's modulus of the material to be transformed over the Young's modulus after transformation. Okay, that's the way we can work out. So remember, please practice. This is very important for you because this is from real question for the last few years. Okay, that's why I always mean this is from somewhere, letting you know. So that's why please keep practice, understand how we can work out these questions. Okay, so that's the one way. And we have a last tutorial questions on the material for here. This is for transformation. This is for the aluminum alloy. The column so has a length of 6 millimeter, 6 meters, and fixed in one end. Look here, fixed in one at one end and a pin at another. Okay, so that's why from here we must know we use this equation and get where is one fixed, one is on the pin. So that's for the shell. Clear? That's why the what kind of equation will be. So of course the cross section will be here. So then if the cross-sectional area has the dimension shown as I beam, so determine the critical load. Of course, this yield stress is 250 megapascal and the Young's modulus is 73.1 gigapascals. So of course, based on this one, we have a clear idea. So what kind of structure will be used? So of course, we can get say PCR is equal to pi square E R minima over KL square. Okay? So of course, based on one, of course, this one should know what kind of thing will be used. So of course, this one will based on the question itself. This structure will be this. Okay? So of course, this one based on that, we can work out. And the K will give to you. Also, we'll put this one up to yourself. Okay? So that's why I prefer use the equation from general equation first. So of course, based on this one, we should work out the area X, Y. So of course, it's IB. We have a lot of way to do. So that's why from here is R is order in the center. Okay? If this X is Y. Okay? So of course, we can know RX, RY. So anything here we can know. Okay, it's x, x, y, y. Okay, Rx is equal to 1 over 12 BH cubic. It's a BH. Ry is equal to 1 over 12 HB cubic. For the RB, you can work by yourself. Okay, so from here we can work on the area. So area we can work on it easily because these have two, one top, one bottom, one's midway. So quite easy for us to work out. So you see from the top 1.3 times the height. This one 10 plus 0.2 plus 0.01. So this whole thing minus 0.3 minus 0.01 times the height, okay, 0.2. So that's why we can work on here. 8 times 10 to negative 3 square meters. Same way we could work on Rx. So 1 over 12 B H cubic minus H. So as well from here we can work out is 72.8667 times 10 to negative 6 meter per 4. Our we can do the same way, okay? So this one I use two ways to work out. So remember, this I will not repeat. So I just write down the equation for you. Work out. This from easy knowledge. If you still don't know, I really worry about you because it's the basic thing. So I mentioned I will not repeat all the thing again and again. I just write down this thing for you. Okay, from lecture 2 to 22, we will start this thing, and then on we'll put a lot of things over I-beams and then rectangular. So that's why you should have capability to do this kind of work. I will not repeat all the if otherwise we cannot do anything. If every time we do is please use parallel, axis, theorem, everything we do, we cannot do anything. Okay. So of course, based on this one, because Rx is greater than Ry, so this means the R minima should be equal to Ry is equal to 45.0167 times 10 to negative 6 meter per 4. Okay, because this one is R mean. Oh, sorry, is R mean. So that's why from here we should get these things. So then later on, we should work on the PCR is equal to pi square ER minima over KL square. So from the knowledge, as with the pi square times E will tell you 73.1 gigapascal times R minima, we just work out, over K would mean to you from here should be 0.699. I just say 0.7 times L will tell you the length will be 6 meter. Okay, so the one with times 6 meter square. So then we can work out these things. 1.84 times 10 power 6 newtons. So remember when we here is not finished. Not finished, okay? That's why we still should do verification. So we work on sigma CR is equal to PCR over A equal to 1.84 times 10 power 6 newtons over the area we work out is 8 times 10 to negative third square meter. So that's why from here 230 times 15 megapascal. So because 230.15 megapascal, so this is for sigma CR is less than 250 megapascal. This one for sigma 1. Sigma 1 is here. Okay? So sigma CR is equal to 230.50 megapascal. So PCR is equal to 1.84 times 10 to power 6 newtons. So remember, verification is very, very important. This is really, really important for this. Then, of course, the sigma should be equal to sigma 1. Yeah. Okay, that's why this is very important for you to realize. So that's why for you, you should get this idea. You must get the idea to do it, okay? So everyone must understand this part, okay? This is why it's so important for you. Okay, that's all for this. Thank you very much.